Okay, so how to factor? So again, I said if I have something like that, x squared minus 4, this is equal x minus 2 times x plus 2. So I said from here to this way is called factoring, and from here going back is called expanding. And I start from the first example. So the first example is example. Who will give me the first example? Because I was it. I think it's 6x squared, stuff like that.
No, it was 3x squared minus 6x.
3x squared minus 6x. So again, the 3x squared is equal, if I want to factor it, is equal 3 times x minus, if I want to factor number 6, is 3 times x. Okay. Now again, we're looking for the similar. So the similar is 3 and the x, 3 and x. So the factor is going to be 3x for both terms, and the remains is x here, and here the remains is minus 2. So this is the first one. Second one is, who will give me the second example?
8x to the 4th power plus 4x squared plus 2x.
8x to the 4th power plus
4x squared.
4x squared plus x, I think.
2x.
2x. Okay, the same idea exactly. Who will do this one?
2x.
2x. But how you think about this one? Like how you factor like the previous example? You use the same idea. What's the factor for number 8?
2 and 4.
2 times 4. And what's the factor for 4?
2 and 2.
2 and 2. So what's the factor for x to the power 4? X times x times x times x. The same things for 4x. How you think for the second one? Plus, same things. 4, what's the factor for 4? Is 2 times 2. What's the factor for x squared? X times x. And the same things for 2x. What's the factor for 2x? Is the same as 2x. Now we're looking for the similar. We have 2 here, 2 here, 2 here. We can like remove the 2. 2 with a 2 with a 2, and we brought it down 2. Here we have 2 with this 2. No, we don't have that. We cannot do it for the third one. So why? Because we don't have 2 in the third term. So because here we're looking for something are similar in this term with this, with this. What about the x? Yes, we have x here, we have x here. So we can remove x by x by x. So it will be here x. Okay. What remains? Nothing. That's it. So now we open parentheses. The remains of the first term we brought here. The remains here, 2 times 2 is 4. I'm going to use different color. That means here 2 times 2 is 4. And x times x times x. X to the power what? 3 plus. Here we have 2 only, and we have x2. So 2 times x, 2x. What's the remaining here is 1. Don't forget the 1. So give me 1 more. So this is the factor for this one. Any question? Make sense? Anyone has a question how to factor? This is like step by step. Next time we don't have to do everything step by step. You can just factor it right away. You said we have x here, we have x squared, we have x to the power 4. So the greatest common between the variable x and x squared and x to the 4 is x. And the 2 and the numbers 2, 4, 8. What's the greatest common factor between the numbers is 2. So you put 2x. Now you dividing this by 2x, you get 4x to the power 3. Same things for the second term, same things for the third term. Okay. Now let me give you another example. Factor this one. 2x plus 4 times x minus 3 minus 5 times x minus 3. How we can do this one? Who has any idea? What's the greatest common factor between this term and the second term?
X minus 3.
X minus 3. This is the greatest common. Somebody asked me the answer for example 2 is the number in green. No, it's okay. It's the yellow and the green. So let me make it one color. So the answer is 2x times distance 4x squared x to the power third plus 2x plus 1. So here the greatest common factor between this term and this term, we're looking for what similar in the between the first term and second term. It's look like x minus 3. What about the numbers? 5. We don't have numbers, we have 1. So the greatest common between 1 and 5 is 1. So the answer is x minus 3. We open parentheses. What's the remaining here? So this one is done. I put outside as the greatest common factor, the x minus 3. The remaining is this parentheses, 2x plus 4. What's the remaining here when this put outside x minus 3 is the negative 5. Can I simplify these things more? Can I simplify this one? Yes, we have
Yes.
plus 4 minus 5, right? So what is the answer? X minus 3 times 2x plus 4 minus 4 minus 5. I write it again is equal x minus 3 times 2x plus 4 minus 5 is
Negative 1.
negative 1. So this is the answer. This is the factor for example 2.
Professor, I had a question.
Yes,
Why wouldn't you distribute the -5 if it's on the outside of the parentheses?
distribute the negative 5.
Yeah.
how, what do you mean? Like
No,
how?
not there. On the other side. Where? Not that side. The other side. Yeah, on that side.
Okay, because we have here minus, we cannot distribute. When we going to distribute? So we distribute if we have multiplication. If here multiplication, multiply, we can distribute the 5. But if we have minus or positive, subtract, or we add, we cannot distribute. Make sense?
Yes, thank you.
No problem. Any question? Now, factoring trinomial. Factoring trinomial. What is the meaning of trinomial? Last time I talked about these things. What is the
Three
trinomial?
terms. Three
Three
terms.
three terms with different exponent. Like anything of the form ax squared plus bx plus c. This is called trinomial. Why? Because we have different terms with different exponent. 2, 1, the exponent here is 0. X to the power 0 is 1. Such that a, b, c not equal 0. A and b and c not equal 0. This is called trinomial. But in this class, we're going to factor trinomial. First things, I'm going to factor something like that. If a is equal 1, x squared plus bx plus c. Second things, if a is not equal 1. So in this class, I'm going to do if a equal 1. And also I'm going to do if a not equal 1. Because we have different way. If a equal 1, then x squared plus bx plus c. I'm going to factor something like that. So let me explain it more. So if a equal 1, then the trinomial would be look like x squared plus bx plus c. And this is, I'm going to factor it to something look like this. X plus r, x minus or plus c. That's, I mean, such that r times s, this number, times this number, they give me c, this c. And r plus s, they give me the middle one, b. Okay. So let me explain what I said here by example. The example now 1 is factor x squared minus x squared plus 7x plus 12. How can I factor something like that? There is, he come back again. I think one of the class, he sent this link. Okay. Who's one of the class, he has this link and he sent it to Twitter because he wanna lose the class for us. Okay, so how can I do these things? X squared plus 7x plus 12. So I have open two parentheses. First one is x. Here we have to see a is 1. Look, a is 1. So we have to look for two numbers such that the multiplication is 12
Yeah.
and the addition of these two numbers is 7. So what's the factor for 12?
4 and 3.
3 and 4. Exactly. What else? Which was the number if I need two numbers. If I multiply these two numbers, they give me 12.
2 and 6.
2 and 6. Exactly.
Yeah,
What
but it's 3 and 4. And
2 and 6. What else?
1 and 12.
1 and 12. Good. Perfect. One and 12. Okay. So right now I check this is the factor for number 12. Is 3 and 4, 2 and 6, and 1 and 12. So now I have to check, is the addition between these two numbers is 7? This the addition between these two numbers is 7? Is the addition between these two numbers is 7? So let me check. Wherever they give me 7, so I'm gonna choose this option. So 3 times 7 times 4 is 12, and 3 plus 4 is 7. Oh, it's gave me from the first time, so this is what I need here. But if I look into the second one, 2 plus 6, they give me 8. And this is not 7, the middle one. This is not 7. So I'm not going to choose this one. But the third one, the same things. What plus 12? They give me 13. And 13 is not equal to the middle one, the 7. So I'm not going to choose this one. So I'm going to choose this one because 3 plus 7, 3 plus 4, they give me 7. So how can I explain these things? How can I factor this one? They give me two parentheses.
x plus 3
Plus 3, exactly.
plus
X
4.
plus 4. This is my answer. Okay, any question? How I can like factoring stuff like that? Okay, let me do another example. If I have something like that, x squared minus 2x minus 3. How can I factor something like that?
-3 and plus 1.
So I have to first things factoring this one, like Salim he said, -3 times +1. What else can I factor this one? What another numbers I can like choose any two numbers such that
You could do
fact
+3 and -1.
+3 and -1, exactly. What else? That's it. We don't have another option. Now, let me check. Is -3 plus 1? They give me the middle one. They give me -2. Oh, it's giving me like from the first time. This is will work. The second one is not gonna work. Why? Because 3 minus 1, they give me 2. 2 positive. And 2 positive is not the second term. The second term is -2. So I'm gonna use this factor. So I open two parentheses. First things x. Here we have -3 and +1. -3 and +1. This is the factor for this example. Any questions so far? Makes sense for all of you how to factor? Here we learn when a is 1. Now we're going to learn when a is not 1. Okay. So when a is not 1, so when a is not equal 1, so I'm going to factor something like that. Ax squared plus bx plus c, such that a is not 1. Here we're going to use the idea is called trial and error. It's called, so we're going to use the idea is called factoring by trial and error. Okay, how can I do these things? I'll explain this by example. The question is factor something like that. 3x squared plus x plus 4. So look, here the leading term is not 1, it's 3. So this is, we're going to use the idea it's called trial and error. Who will give me an idea how to solve something like that? Who will see something like that?
So
We multiply A and C.
We multiply a and c. We multiply a and c. Yes, we can. We're gonna use something like close to like to this idea. So I will, for something like that, first things we have to factor this number. Then we're going to factor this number. What's the factor for this number? Then after we factor everything, we're going to trial and we check which of the factoring works together. What's the factor for number 3?
3 and 1.
3 and 1. Perfect. Here, what's the factor for number 4?
2 and 2.
2 and 2. 2 times 2. What else?
4 and 1.
4.
Hold on. Because this one is not gonna work, let me change it to the minus. Here. Now it's gonna work. So x minus 4. What's the factor for the minus 4?
-2 times 2.
Negative 2 times 2.
Or -1 times 4.
So negative 2 times 2, or what? Negative
Or
4,
-1 times 4.
4 times 1, and what for negative 1? What you
Times
said?
4. -1 times 4.
Times 4. Okay. Or we have another option is negative 2 times 2 and also 2 times negative 2. Or we have different option here, 4 times negative 1. Here we have another option is 1 times 4, negative 4.
Isn't it the same thing?
No, it's different. All
Why?
of them give me the same number, minus 4, but I have, when I do factoring, this guy here different about this one, or this one is different about this one. The minus here in the beginning, but the minus here in the back. I will show you how. So now we open two parentheses. So this is equal. We open two parentheses. In the first parentheses, we write here, like we fix these things. We write x inside, and here is x. We put 3x and 1 because we have factored the first term. Now, we have to choose one of these such that if I plug it inside here and I do some like steps, they give me the middle one, the x. So let me choose the first one, for example. I put it inside. The first one is -2. Here I put here -2 and 2 plus 2. Then I have to do this step. The step is we have to multiply this guy by this one and multiplying this guy by this one, and I do summation between all them, and this answer must be give me 1x, the middle one. So 3x times 2 plus this guy times this guy, x times -2. What is the answer? 3x times 2 is 6x. X times -2 is -2x. And the answer is 4x. Is not the middle one here, is not x. So my choosing for this one is wrong. It's not gonna work. Make sense? Because the answer is not 1x. So my choosing for -2 and 2 is not going to work. So I remove it. Make sense? So what I have to do next?
Try the next one.
Try the next one, 2 and -2. So again, open another parentheses. Open other parentheses, and I choose the second one, the 2 and -2. So I have 3x here, and I have 1x. Now I'm choosing +2, -2, +2, -2. And I do the same step like before. So again, I multiply this by this, and this one by this one. What they give me?
-6x.
-6x. 3 times -2 is -6x. Plus what? Plus 2 times x, 2x. And they give me -4x. And the -4x is not 1x, the middle one. So this one is not equal 1x. So this is mean I have to remove this one. It's not gonna work. Okay? Again, I go back to this one, -4 and 1. I'm going to do it here. I open two parentheses. Such that the first parenthesis has 3x and the second one has x. So 3x and x. And I have -4 and 1. -4 plus 1. I do multiplication again. And I check. is 3x times 1 is 3x. 3x times 1 is 3x. Minus 4 times x minus 4x. What is the answer? Minus x. Is minus x equal positive x? Is not equal 1x positive x. This is mean this one, I'm not gonna use it again. Okay? I check this guy again. 4 and minus 1. Open two parentheses. 3x and x. I have 4 and minus 1. Positive 4, negative 1. I do multiplication. 3x times minus 1 is minus 3x. 4 times x is plus 4x. And they give me x. Oh, it's same like this one. The middle one is equal 1x. So this is what I need. So this is my factoring for this trinomial. So this is the answer. Makes sense? So this is the first step. It's not gonna work. Second one, it's not going to work. Third one, it's not going to work. Fourth one is worked by these two numbers, 4 and 1. Makes sense? Any questions so far?
So there's no simpler way to do this, but like to do all of this try and error till you find the right answer.
This is the simplest way.
Oh,
There's no simplest than this way. It's called trial and error. You
all
have
right.
to check the first one, second one, third one, until you get the answer. If you get the answer, you stop. So in this one, I stop at 4 and minus 1 because I get the one in the middle lane, the middle term, I mean, x1. Okay?
Can you do another one?
Yeah, I will do another one. Another example. Here, it makes sense. Any question for this one? Another example. The example is factor this one. 7x squared plus 37x plus 10. So the same idea exactly. I factor this number and I factor this number. What is the factor for 7?
7 and 1.
7 and 1. What else? That's it, 7 and 1. Even if I like 7 and 1, I don't have to write or 1 and 7 for this case. The same things. So the first one, like in the first term, just 7 and 1. I don't have to write or like 1 times 7. We don't need it. For the second one, it's matter. I have to write it like that. What's the factor for number 10, the positive 10?
5 and 2.
5 and 2. And what else?
1 and 10.
1 and 10. What else? That's it, right? Okay, so now,
Yeah, but you have to reverse.
or 2 and 5 here, or 10 and 1. So now we're going to try. We open two parentheses. For the first parentheses, we have 7x. Second parentheses, we have x. Again, doesn't matter. We don't have to write or 1 and 7. For the first term, we don't have to write it. But for the second term, it's matter if we flip it or not. So we have 7x and x. Now let me try the first one. 5 and 2. So plus 5 plus 2. So I took the first one here. 5 and 2. Now I multiply this one, and the 5 by the x. What I get? 7x times 2 plus 5 times x. What is the answer? 7x times 2 is 14x plus 5x. You give me what?
21x. No, 19.
19x. So they give me 19x. And 19x is not the same as the middle term of this trinomial. Is not equal 37x. So this is mean
The other one is correct. 2 and
I'm not,
5.
so I'm not going to use this one. So this is x here. Second one. Let me check the second one. 7x plus 2 and x plus 5. Multiply this guy by this one by this one. So 7x times 5 plus 2 times x. They give me 7x times 5 is 35x,
35.
and the second one is plus 2x. They give me 37x. So this is exactly like the middle one, the middle term. So this is gonna work. So the factor for this trinomial is this one. This is not the factor for the trinomial. Not work. So this is good. It's work. So this is the factor for this trinomial.
I have a question.
Yes.
So on the quiz, and you ask us like to factor this trinomial, you
Okay.
just want us to write what's in the parentheses, right?
Yeah, you have to know, you have to assume what's inside the parentheses. Like you have to know what's factoring for the for the first term, factoring for the second term, and you have to try. And the quiz, inside the quiz will be like more easier than this. Like they give you because the time, so you cannot like lose it. They will not like be like hard trinomial factoring. Like it will be like something possible, easy to do it, easy and direct. Yeah, okay. So for quiz, I'm going to give more times when you have question like that. I give you more times to do something like that. Any questions so far for for this trinomial factoring? Okay, so we finish the trinomial factoring. Now I'm going to give you another example when I'm going to give you the special factoring formulas. So we have some special factoring formulas. Here, Chris, he asked me only one set of factoring can be answered, or can there be? Okay. For factoring something like that, the answer will be like only one set. I mean, when you find this guy 2 and x is working, this is mean this guy will not work, this guy will not work. Even if I try it, they will not work for 100%. And this one, they will not work. So the only one who work, this guy, only. No one behind this one will work, only this guy. And the same things for this one. This example, the only one will work for this factoring is 4 and minus 1. I mean, the minus 1 and 4 will not work, and 1 and minus 4 will not work. So only one answer, yes. So now, a special factoring formula. So first things we have to know, a squared minus b squared, this is give me a minus b times a plus b. This is called the difference of squares. Second things, I have to know a plus b squared equal a squared, the first term squared, plus 2 times the first one times the second one, plus the second one squared. The first term squared plus 2 times the first term, second term, plus the second term squared. This is called the perfect square, if you need a name. The third one is the similar to the second one, but the difference it's the minus. A minus b squared, this is equal first guy squared minus 2 times the first one, second one, plus the second one squared. So how can I use these things? I gave you by example. The question is factor by using the special factoring formulas in above. Factor 4x squared minus 25. How can I factor something like that? I give you like 1 minute to think about these things and give me the answer. Or tell me how you think to give me the answer.
Since the x is raised to the power 2, you could simplify the 25 and make it 5. So it's going to be like 2x times positive 5.
Times positive 5.
Yeah, that's what I meant. Yeah. then 2x minus 5. Yeah.
Okay, so he said I can factor these things by 2x plus 5, 2x minus 5. This is true, but let me explain more. This here actually look like 2x to the power 2 minus 5 to the power 2. Look, this is exactly like this. 2x, all of this to the power 2 minus 5 square is exactly to this formula. Why? Because 2 squared is 4, x squared is x squared, the minus is minus here, 5 squared is 25. Now look into this formula in the special factoring formula. Look to the difference of square. This is the first one. A squared minus b squared. It's exactly look like this one. So my a is 2x. This is my a. And this is my b. And go back to the formula. A squared minus b squared is equal the first one minus the second one times the first one plus the second one. So this is equal exactly a squared, this is b squared. And again, it's equal a minus b times a plus b. So okay, I will do it for the numbers for the formula. So this is equal, my a is 2x. I open two parentheses. My a is 2x. My b is 5, so minus 5. My a again is 2x. My b is 5 again, plus 5. So this is the factoring by using the special factoring formula, difference of square. Any question? Make sense for all of you? How I think for something like that? Okay. Another one. Factor something like that. Another example. Sixteen x squared minus 4. What's the factor? What's the
Is it
factor?
4 and 2?
4 and 2. This is the factor of 16. But how you do it, like by multiplying by difference of square? How you think about this one? Like give me the answer, parentheses times parentheses. Like this.
4x
4x
minus 2,
minus 2. What's the answer?
4x plus 2.
4x plus 2. Perfect. Correct. So he think for this one as exactly 4 because this is look like, yes.
Yeah, how did you get the factors?
How did you get the factor? Okay, so 16x squared, it's look like 4x, all of this square minus the 4 is equal actually 2 to the power 2, as we learned in the section B2, the previous sections. So 4x, all of this to the 2 is mean exactly 16x squared minus the 4 is equal 2 to the power 2. Now we're going back by using the difference of square. Go back here. Said a square minus b square equal the first term minus the second term times the first term plus the second term. So my a is 4x. This is my a. Here, this is my a. And the 2 is my b. So I get a squared minus b squared. So applying the formula, they give me 4x, this is my a, minus the b is 2 times the first one is 4x plus, here the plus here, plus the second term, 2. So I get the same answer like Salim he said. The third formula, it's called perfect square. Any question? Okay, let me give you example for perfect square. Four x plus 2, all of this square. How can I use the formula? I give you 1 minute to think about it.
Is it 16 squared minus 4? I mean, plus 4, something like that?
16, what you said? X square plus what? Plus what? What you said?
Oh, I said 4.
Plus 4. Okay. So again, by using the formula said if I have a plus b, go back to the formula, the previous slide. A plus b square is equal to the first one square plus 2. Don't forget the 2 times the first one times the second one plus the second one square. So this one equal a square plus 2 times a times b plus b square. So he said the first one square plus the second square, the second one is square, but he forget this one. This is equal plus here plus 2 times the first one, 4x, times the second one, 2. So this is
Well,
give me,
I got the answer.
yeah. So
16x squared plus 16x plus 4.
16x plus 4. Yes. So don't forget this one. When you see multiplication like that, first one square plus 2 times the first one times the second one plus the second one square. Make sense? It's clear? Okay, now in the last 10 minutes, let me go to the next slide. P7. is called rational exponent. I give you a brief for this section. I'm going to explain more next time. Rational exponent. I mean like rational expression, sorry. So what is the rational expression? So rational expression, the definition, is a fraction expression such that inside of the denominator and numerator, both of them polynomial. I mean, let me give you a brief definition for that. Is a fractional expression. I mean, for fractional, we have numerator and denominator such that both of the numerator and the denominator are polynomials. I last time explained what's the meaning of polynomial, and I give example which expression is polynomial and which of them not polynomial. So if you need like to review the polynomial, go back to the last previous class. So I give you example for what I said, or I give you like different things. It's called rational. If I'm looking for the rational expression as something like that. So here, the rational expression it's look like fraction such that here is polynomial over polynomial. Polynomial over polynomial. I give example. The example is saying which of which of this expression is rational expression is rational expression. So again, to know the expression is rational expression, it's supposed to be polynomial over polynomial. So for example, 2x over x minus 1. Second example is y minus 2 over y squared plus 4. Third one is x over square root of x squared plus 5. So the question is, which of this expression is rational expression? The first one is a rational expression, and why? Is this rational expression? Or in different way, is this polynomial over polynomial? Is 2x is a polynomial?
No.
Is 2x a polynomial? Yes, it is polynomial. Why? Because last time I said 2x has exponent 1, and the 1 is belong to the natural number. If you go to the previous class, natural number or 0. So this is 2x is a polynomial. What about x minus 1 is a polynomial?
Yes.
Yes, it's a polynomial. Why? Because the variable x has exponent 1, and x minus 1 is polynomial. So polynomial over polynomial. So this is a rational expression. For the second one, is it a rational expression?
Yes.
I asked you myself, is the first in the numerator is a polynomial? Yes. Is the denominator is polynomial? Yes. Why? Because the two belong to the natural number. Here I have 1. This is belong to natural number. So this is a polynomial. Yes. So this is both of them is a rational expression. So the answer yes. What about the third one? Is a rational expression? This is rational expression. If the numerator is a polynomial, yes, this is a polynomial. But this is a polynomial. Radicals. No, it's not a polynomial. Because we have radicals. We have square root. So this is mean this is not a rational expression. It's not.
You said the square root is what makes it not natural or not rational.
Yes, because if I'm looking for this guy here, square root of x squared plus 5, it's look like x squared plus 5 to 1 over 2. And something like that is not a polynomial. Something like that is not a polynomial. To be a polynomial, like I said last time, so polynomial anything look like ax to the power an plus an minus 1 xn minus 1 plus ta plus a1 x plus a0. And I said this guy, all the a's are real numbers. And the x, both, all of them are variables. And also the n here, n minus 1, the n's is natural number. Or 0. What's the natural number? Is 1, 2, 3, 4, 5, 6, 7 to infinity. This is natural numbers. No fraction. No fraction. The fraction is not natural number. The fraction is rational. Any fraction is rational numbers. Make sense? So we're going to stop until here today. And next time we will continue for this section. Any questions so far?
Last page. Is it safe to say that anytime you see like the square root that it will not be rational?
Will not be if you see something like square root, it will not be rational expression.
Never, right? Just
Never.
never.
Never. Okay.
Thank you.
Never. So I'm going to stop until here today.